Hello and welcome to section 10.4. In this video we'll be going over example 1, which shows how to set up a table that we can use to keep track of the different composite body parts. So composite bodies are basically made of geometric shapes: circles, squares, triangles, rectangles, and we combine them by adding them together, subtracting them to make more complicated shapes. And we can find their area moment of inertia by using things like parallel axis theorem and then adding them up at a common axis. So you get tables that look kind of like the ones here in the examples that help you to organize that. You don't have to use them, but I recommend using them. It makes it a little bit easier just to make sure you got all your parts. So we have that here. So this is example 1 redrawn. So parallel axis theorem basically states that if I want I about some point, that is equal to the same I about the center of gravity or the centroid or the center of mass. Again, for a lot of these things, they're the same point unless there's something special going on, plus the area of that subshape. So if it's a circle, it's just the area of that circle. In our example, we're going to have the three areas of the three rectangles, and then the distance squared. So this will be the distance from the axis. Now, important is this distance is between the axes, and the axes must be parallel. Otherwise, we can't use this. Okay? So for our problem specifically, it looks more like this. We're trying to find IY. We're not actually going to find it. We're just going to set up the table to find it. So about some new thing, so we might actually call this IY prime instead of IYG. So you could do it a couple of different ways. So I use P because from dynamics, we typically do this about a point, but we can do this as a prime because we're going to be doing it as an axis here. So IY or IX will go up here as well. So IY about some new axis to the centroid, y-axis, area distance squared. So I'm going to find all these pieces. So IG, A, D, and then what will happen is over here I could calculate IY prime for each of these, and then do a summation at the bottom. So that's the strategy. So let's do that real quick. So I've color-coded my shapes here. So shape 1 is this big rectangle. Shape 2 is this little one on the left. Shape 3 is this little one on the right. Typically, I'll just circle them and write in the number. But if you have colors, it can make it a little faster. So we need to have, so these are all rectangles. So what we need is an equation for rectangles. What is their area moment of inertia about their y-axis? And if you look in, I believe it's either the front cover or the back cover. I think it's the back cover of this book. You're going to find out that there is an equation that says that IY to the center of gravity is 1/12 height base cubed. If you do IX, it'll be base height cubed instead. So we're going to do that. So we're going to get, all these are going to be 1/12 whatever. So the height of this is this 200, 250. I'm just going to leave things as millimeters for right now, but we can always move that around if I really needed to. So so we have 200 and 200, which is 400, 450. If you wanted to turn it into meters, you know how to do that. And then our base, so this is only this wide, which is 50. Then we're going to cube it. For shape number 2, it's also going to be 1/12. Its height is just 50. And its base is 150. Cubed. Same thing for the blue one. They're exactly the same, actually. The area, so area, if you don't remember, is just base times height for these things. So I have the base, I have the height. You could actually program a spreadsheet to do this for you, because there's a lot of this. We're just pulling out the same numbers a bunch of times. So base is, well, it doesn't really matter which order they are. but I just want to be consistent. So 50, height being 450, base here being 150, and height being 50, 150, and 50. And then to make your life easier, what you'd do is you probably would calculate the number over here off to the side. So for instance, you might say that that 450 times 50 is 22,500, or 22.5 E3. Because ultimately you want to get all the numbers. And don't be afraid to use your E3s or your kilos or whatever, just to kind of get things cleaned up. Now, what you don't want to do is don't put this in meters and this in millimeters, because that'll just, all sorts of bad stuff will happen. And then our distance is how far away are we from the axis. So in this case, we are trying to get to this y-axis here. So we're asking basically how far in the x direction, so this is actually a dx if it helps. So the distance in the x direction, do I need to move to get there? So for the pink one, I don't move at all. It's already on it. For the yellow one, I'm going to move over this way. So x is defined as this way, so that's a positive. So it's 150 over 2. So it would be 75 millimeters. For this one, it's going to be a negative 75 millimeters. It doesn't really matter if you include the negative, though, because the distance is going to be squared. And then you would go through and do a calculation and add all these up. So I'll do each of these real quick and show you the numbers. All right, so you should get something that I believe this is the right answer. I don't have it handy with me, but yeah. Again, all we did is we just used parallel axis theorem, wrote out the pieces of parallel axis theorem. So we wanted to find this piece, and this piece, and then we just did our calculation here to get these numbers. All right. Hopefully it helps. If you have any questions, feel free to reach out.